Okay, so what I've done is I've made a brand new project folder. Does anybody still want to see how to import from Git?
Please. Yes. Please. Yes.
Okay, so I started out brand new, fresh, nothing there. So you can go and make any new workspace you want. Started out completely empty. I just got rid of the welcome screen. I'm going to go back and find the Comp 132 site, the one that looks like this. I'm going to press on the source button, and the source button gives me a URL. Okay, so just copy out the URL portion of that and nothing else. Ignore the command line options, and then go back into Eclipse. Under Eclipse, you say File, Import. Choose the option that says Projects from Git. Say Next. In my case, it says Clone because I own it, I think. In other cases, it'll just give you, say, a URI option or URL option. You'll end up with a dialog box that looks something like this. You paste in that URL and it reformats it into the dialog box, except for the little tiny space that you have to get rid of in the first field. And then click Next. Click on Master just to make sure it's selected. Click Next. And in this case, what's happened is it's popped up and said, oh, look, that directory isn't empty. And it's because I've already got a Comp 132 folder in my Git folder someplace. So I'm going to go back to my file browser, and I'm going to find my old Comp 132 thing that I don't need anymore, delete it. So now that Git folder doesn't have that thing in there anymore. Go back and fool it again. Now it's happy because it can remake that folder. And click Finish. It brings up the list of all of the thing that you're supposed to click on. Anyway, this is just a whole sequence of yes, 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 until eventually you get to all of the projects that are in there. And the default one is select them all and click Finish. And there's all the source code that we've worked on so far. Okay? My recommendation, if you want to play with it for some reason, the best thing you can do for yourself is right mouse click, do a copy to copy the entire project, and then do a paste again, and it'll be pasted in as a project where you have to change the name, and you've now got a local copy that's different from my original pristine copy. And there's all of the class source code. If you're having trouble with trying to get it updated, throw away the stuff that's in your Git folder that says Comp 132. Make a brand new workspace, and you should be in business to just download the whole thing again, because that master copy is always going to be there. Okay? So there's all the class source code. So now let's add another project. I'm going to put it in the same workspace. I'm going to make a Java project to do bicycles, because I feel like a bicycle. Okay, crack open the project, click on the SRC folder, and now let's talk about something that represents a bicycle. I want to make a class that keeps track of information about one bicycle. Okay, so there's the noun idea. It's a thing. Okay, so we'll go and we'll say, well, since it's a thing I'm trying to keep track of, I'm going to make something that represents just one bicycle. Doesn't have to have a main in it at this point. It shouldn't have a main. It's not going to do anything. So this is the level below that we talked about, the main thing that's driving it. Okay. What information do you want to record about a bicycle? If you were to get one, right, and you reel this bicycle up and somebody looks at it, what's a question that they're going to ask you?
How much? Price?
Price, yeah, who cares?
Gears are
How
on
many,
it?
how many speeds it has, there's a good one. I mean, particularly if you grew up in an era where there were only 1 speeds or 3 speeds, having, the first question that people generally asked was, hey, how many gears or how many speeds are on this bicycle? So let's keep track of that. So all of the variables in Java in this section are gonna say private on the front of them. It's a number, and we'll call this, what, number of gears? Or gears. How do you like that variable name?
Well, it doesn't tell you which style of gear it has, whether it's the front or the back.
So I want total gears on bicycle, which is really the maximum number of gears. So maybe maximum gears is a better name. Okay, so there's just one piece of information. Anything else you might want to report about the bicycle?
Its age.
Yeah, its age, yeah.
The color.
It's what?
The brand. Oh, the brand.
The brand. So there's lots of stuff, right?
Whether the seat is comfortable.
I mean, yeah. I mean, the whole point of this is that it's a form, right? And what you're trying to do is you're basically trying to say, what would be the useful stuff that I would record here? What would be the stuff I want to keep forever and ever, right? So of all of those suggestions, I'm just going to pick one for the moment, and then we'll think of some more, right? So either, in general, either it's going to be a bunch of integers for values, a bunch of numbers, or it's going to be a bunch of strings to record text-based stuff. And that's all that's ever going to go up here. This is just the common information that you're trying to put on the form.
Possibly a Boolean for whether or not the brakes work.
Yeah, we'll get to that. We'll get to that. Now, here's the problem with bicycles is that what we're doing is we're doing this thought experiment about what a bicycle might be and what we might want to use it for. And the best thing that you can do for yourself is actually go get a bike and try to ride one and do something with it, okay? And so the doing something is, let's go write a main program to just sort of try this thing out. Oh, let's go order one. Let's go see if we can make it do something. And then we'll figure out from the doing what we should actually try to get this thing to record or what it's going to actually have to do. Okay, so what I'm going to do is I'm going to go back and I'm going to make a main program, and I'm just going to use it as a place where I can test out ideas. So it's the bicycle driver. Okay, and make sure you click on main because this is the thing that's going to actually do some work. Get rid of those silly comments. So, how would you go about making a bicycle in Java? What do you have to say to get one produced?
Generator the bicycle frame, like male or female.
What's the key word in Java that makes one? New says, go out and make me one. The thing I would make is a new bicycle. Okay. Well, if I've made a new bicycle, new is going to tell me where that particular bike hides. It's going to give me some information that I need to keep. So I'm going to make a variable to keep track of it called myBike. So notice I'm working backwards on this line. If that's the variable that's going to hold on to a bike, it has to be specific and say this variable can only talk to bicycles. Okay, so that's why the thing on the right-hand side is what you're planning on making, and the thing on the left-hand side is where you're planning on putting it, and you have to be specific about the kind of variable that's going to keep track of it. So it's not an integer that's coming back, it's not a number, this is something that we can refer to an entire bicycle with. Okay? Well, okay, so think of new bicycle as being ordering it from the factory. Okay? So if you order your bicycle from a factory, what piece of information are you going to have to give?
Transaction.
What information did we just presume was something that we wanted to report? Gears. So when you order the bike from the factory, you're going to have to say, I want a bicycle with this many gears. Okay, and so we're going to make people say in here, when they order something from the factory, they're going to have to supply some information about how they want their bicycle to look when it comes back from the factory. Okay, so that's what that number is going in there. If you put a number in there, then you have to go back into the bicycle class and you have to make that function for the constructor to call, which has to have the same name as what we wrote in the other one, and we were passing in an int, a number that we thought was going to be that number 15 coming in. So if somebody's giving you this piece of information from the outside world, you need to store it someplace. And so we're going to take the number that they give us, that number, and we're going to store it into the place where we're recording it on our form, which is that variable. So this is just transferring the information into the appropriate spot on the form. So, there's our bicycle. We actually, if we save this, that'll get rid of the errors in the main program. And now we've got something that makes a bicycle, and the only thing that it keeps track of on the form is the number of gears. So there's my bike sitting there. Somebody comes up to me. What's the question they're going to ask me?
Oh, here's your bike.
The only question they've got is, hey, cool bike, how many gears does it have? So the bicycle has to be able to respond to questions. So my bike dot get maximum gears is what I want to talk to it, what I want to say to it. And I'm not going to provide it with any information at all. I don't tell it anything other than, hey, you tell me how many gears you've got. And if you're asking a question, you then need a variable that's going to keep track of the answer. And this is one where you get to make up what that variable is. So this is talk to the bike and say, hey, how many gears do you have? And take the answer and stuff it into a variable so you can do something with it. Okay? The problem here is that we haven't written get maximum gears yet. That's something that the bicycle has to be able to respond to. So we'll go in here and we'll write get maximum gears. Get maximum gears promise is really asking for that variable. And in order to send that variable back out, you have to say return. And if you're sending something back out, up here you have to refer to the kind of thing that you're sending out. The kind of thing that you're sending out has the same definition as this one did, so the thing that you've got to be sending back out is an integer. And that gets the word public on it to say this is something that anybody can say to the bicycle. So all of the functions or the methods are marked with public to say these are things that you can ask me to do. All of the variables are marked with private to say you don't get to look at these or touch these, it's only me that gets to modify. Okay. Should we write a set maximum gears? Why or why not?
You're saying like why would you have a selection interface in this?
No, why would you, do we want them to be able to set the number of gears
Well, you could
afterwards?
You could take it apart, change it if you want.
So one theory is that you could rip out the gear stuff for the 21 gears and you could remake your existing bicycle to give it more gears. Okay, so perfectly reasonable. So if you want your bike to be able to do that, then you have to write set maximum gears and be able to deal with the consequences of what happens if I change this. If you don't want them to be able to change it, if you're saying, I always want this bicycle to be permanently this number of gears, you can never change it, when you're done with it, just throw it away and buy a new bike with more gears, then you don't write it. Okay? And now they just don't have the option of ever modifying that bicycle. Okay? So in this case, I'm going to choose not to modify it. Okay, any other information you'd like to report about the bike? Nah, boring.
Frame type. Right. What direction is it
Female or
facing?
female?
Well, let's think of it this way. You know, I got my bike from the thing. If you wanted to, you could print out what it was to verify that it works, but we'll do that later in a unit test. So you could print out total gears just to make sure it was recorded properly. Okay, so printed out the answer to that question. Got your brand new bike sitting there. What do you want to do with it? Do you really want to look at the color of the bike?
No, it's
What would you really like to do with your bike?
ride it jumps.
Okay, so if you're going to ride your bike, what does that involve doing?
Pedaling.
You got to pedal the bike. So at some point, it makes sense that you're going to say my bike dot pedal. There we go. We're engaging the bike and getting it to do something. Okay, well in that case, I guess we should figure out what pedal means when you actually say it to the bike. So write public void pedal. All right, you physics people, what happens when you pedal your bicycle?
There are physics people here?
Yeah. Really? I have one physics joke too that I'll tell you sometime, but nobody ever laughs.
The bike's position will change.
The world will end.
If you ask an 8-year-old what happens when you pedal your bike, they're gonna say what?
You go fast.
Speed up.
It goes faster.
You fall off.
So you speed up. Or in other words, the speed increases. Now, officially it goes up by, I don't know, whatever gear you happen to be in means the speed increases faster. But for now, let's just do the simplest thing. It goes up a little bit by 1, whatever that happens to be. But it doesn't understand speed because speed is something that we have to record about the bike. So we need to put a variable up there to keep track. That's information that's important to us. And if we put that variable in there, we should make sure that the constructor initializes it. So what speed would you like it to start at when you got from the factory? Hopefully it's at 0. You don't want to be running after your bike as it comes from the factory. So there's speed going up. Okay. Well, I guess if we have a variable like that, we can write public int get speed that allows people to ask the question, hey, how fast are you going? Got it. Anything else that should happen here? What's another obvious thing that you'd then have to be able to do with your bike? You have to brake to make it go slower. So I'm just going to steal pedal. And I'm going to write brake. And if you brake, the speed goes down. How about set speed? No. Can you just set the speed?
No.
So there's no Harry Potter or magic wand thing, you're going 50 miles an hour. It has to go up through the process. Okay, so there's the reason why we're not writing set speed, because you're not allowed physically to just make this thing magically appear at any speed that you want. It has to go through the process of going up or going down somehow by pedaling or braking. And we use the words pedal or brake because they're more appropriate to the problem to say exactly what it is when you see it in the code. Okay? So now in the main program, you can see that it makes more sense that things are starting to go up and go down. So you can pedal a bunch of times if you want. And then if you want, you can turn around and you can do my bike dot brake.
Like pedal times current gear,
Possibly.
or brake times brick wall.
Probably. At some point. But you know, this is the thing that it's an iterative process, right? I mean, the goal is to get it to do something. It might not be perfect, but the speed at least goes up. Right? And we can always go back and we can always change that speed function now that we've got it to make it go up by a factor of what gear you're in and get the physics in there. But one way or another, it's just got to, you know, the speed's got to go up.
By putting the my bike dot pedal in the bracket, what are you actually doing there? Because to me, you'd put a value in there and be able to add them or something, but it seems valueless.
You can only do it once.
Yeah.
I pedaled once, I pedaled again, I pedaled again, and that's the way you make the bike go faster. I hit the brakes once, I hit the brakes again, right? So there's no notion of hitting them harder at this point. You might want to change that later. So for instance, if you could with braking, you might eventually in brake pass a number in so that you can say how hard I'm braking. But for now, at least it goes down. Okay, so that's that rule. It doesn't have to be perfect. It just has to be a little better than what it was, and there's no use getting entwined and making it all complicated at this point. Okay, so there's pedal and there's brake. Any other information that we should be keeping about the bicycle? It sort of relates to what we just discussed about the speed.
Max speed? Minimum?
Wheel size.
Well, somebody said the speed goes up depending on what gear you're in. What gear am I in now? Seems like a fairly important question. So I guess we need to keep track of what gear that we're in now. So we'll write private int current gear. And what should current gear start out at when you get your bike from the factory? Okay, that is effectively saying every single bike that comes out of the factory, somebody makes sure that it's set into gear 1. It's just a standard. It could be set into gear 5, it could be set into whatever, but it's just saying from the factory, this is what you get. And the appropriate thing, I guess, for us is we'll set it into gear number 1. So that means that you can say public int get current gear to send back the current gear. How do you change the current gear? On a physical bike, can you say, oh, you were in gear 3, now you're going to be in gear 5?
Wouldn't you be making an if statement if you can't go below 1?
Don't worry. The question was, shouldn't I make an if statement to worry? The worrying always comes later. Okay? Because if you think of it, if it's a 21 speed bike, you're going to have to go through 20 gear changes or 21 gear changes before it pops off the end. So the rose-colored glasses is to go, well, I'm just going to go ride my bike and assume that things are going to work the way it's supposed to, and I'm not going to go off the end. Okay? But how would you change it? And so in a regular bike, I mean, you know, theoretically there's a front gear and a back gear, but in people's minds it's going gear 1, 2, 3, 4, 5, 6, right, all the way up. So how do you make that happen?
Gear up.
Sure, gear up. So when you gear up, current gear goes up. And when you gear down, current gear goes down. Oops. There you go. Okay. So, we could add something in here, like we could add owner name so that you could scroll the owner, you know, paint your bike with the owner name after you got it. Let's just do that. Suppose that I'm going to add private string owner name in here. Okay, so I decided I want to keep track of who owns it. Where do you want to initialize that? First choice is you could put it as a parameter of the constructor. If you put it as a parameter on the constructor, that says, when I order it from the factory is gonna require me to give some sort of name, because that's the thing that they're going to paint on the bicycle for me. Okay? If you leave it off, then you have to supply a set later, which is saying, oh, I think when I get my bike, it just comes with nothing on it, but I can spray paint a name on it myself. Okay? And if you provide both the argument and the setter, you're saying, oh, I'm gonna get it with the factory name scrawled on it with my name, but if I want, later on I can change it. And if you leave off the setter, then you're saying people can't change it, it just comes from the factory that way. Those are the combinations. Okay? So in this case, if we prefer that the factory doesn't know about it, you can always go and you can write public void set owner name, and you're given some sort of string that has a new name on it, and then owner name becomes new name. Okay? So if I only put that option in, I'm saying you get it from the factory as a generic bike, you have to spray paint the name of the bike on yourself afterwards when you've got it. Which means that in the driver program, after you've gotten your bicycle from the factory, if you want to be really, really sure, the first thing that you do is you say my bike dot set owner name to whatever you want it to be. Okay? So it doesn't come from the factory that way, but I can put my name on it afterwards. Okay? And I did that because I wanted to show you now, here's something with setting a string rather than an integer. And those are the two basic things that you're going to do. Okay, so it pedals, it brakes. Okay, so now's when the worrywarts come in. Okay, so now we get that the naysayers who go, oh well, that current gear is really that's not quite right. We could gear up and we could run our bike off the end of the chain, right? Have the chain fall off, which wouldn't be a good thing. So now the question becomes, how do you prevent it from exceeding the maximum gear?
You'll have to define a balance and maybe a maximum.
We already have maximum gear at the top.
Highest gear, lowest gear?
So when somebody gears up, we need to control the thing here. So now is where the control aspect of the class comes in to make sure that it doesn't do bad things. Okay? So what do you want to write?
If the gear is 21, then just return.
So do you want to do it the bad way or the good way first? You want to practice the bad way first? The bad way would be to say, if current gear is, let's see, 1 less than maximum gear. So if its current gear is less than maximum gear -1, then I guess that means we would do that. We do have maximum gear up there someplace, don't I? Maximum gears with an S. Got it. Then do that. Is that right or not?
Because if you're at maximum, you can switch out. Maybe you don't want to.
So maybe it's not a -1, maybe it's the -1 doesn't belong. Like that.
Just say less than or equal.
Should be less than or equal.
Because if it was equal, then you could go up to 22. Yeah, that's right. Because then you'd be, yeah.
Is that good? Or is there an equal sign?
That's nice.
That's good? Is this right?
Yeah.
How many votes for right? How many votes for wrong? How many votes for don't know? Okay, so here's the thing. We just spent some amount of time with 30 people sitting here scratching their heads going, I wonder if that code works or not. What would be the best thing to do? Make a unit test. Because the unit test will tell you right or wrong. So that's the equivalent of, oh, I'm going to go and I'm going to ride my bike down the street and I'm going to make it go up through all of the gears, and when it hits gear 21, I'm going to see what happened. If I click on it, it should stay in gear 21 and it shouldn't go any further, right? So it's a perfect, so what you would do, if that question came to mind, I wonder if these guys built this thing right, is you would actually go out and try it. You wouldn't argue, you wouldn't look at it and go, well, I wonder if that mechanism is right there. You would just basically take it out for a test drive. Okay? So one of the purposes of a unit test is to make it actually do something bad and see whether or not it performs properly so that you don't have to think about it. So the answer now is you write whatever the heck you want there with less than, equal, minus 1, whatever you want to put in there, and then you say, I'll prove it later, I don't have to think about it now. And if it's not right, the unit test will tell you. Okay, so maybe this is a good time to actually go start the unit testing process. Okay, so to test the bicycle class, instead of let's just try it out, if we want to be a little bit more careful in how we write our tests, we're going to go here and we're going to say let's write a unit test that's going to test the bicycle class. And if you did it right, it will change the name here to bicycle test to say that's the class I'm interested in testing. I always click the setup thing just because it sometimes comes in handy later, and we'll talk about that. And then we always want to include the library, which is the code that manages the tests. It'll pop up with this unit test thing. We can ignore setup, but we can start writing our tests here. Okay?
How did you start that test?
Pardon me?
How did you start that test?
New JUnit test. Okay. The first test when you start these things is you pretty much always want to see whether or not it's made correctly. Because unless you get it from the factory right, it's going to be no good to you to actually go and try to use. Okay? So we'll do a test to see whether or not the bike was actually made correctly first before we actually start to drive it. So the made correctly part of the thing is just testing to see whether or not the constructor does everything correctly. Okay? So let's steal the stuff from the driver program. We can still say, well, I'm going to have to make a bicycle. So it's just like a mini main program. We'll stuff that into the test to get it started. I've made my bicycle. Now, if you get your bike from the factory and it's showing up at your doorstep and you're about to pay your $1,000 for this wonderful bike, you're going to want to make sure, but when you take delivery, that things are okay with it. So if you're taking delivery on these things, what are your expectations about this bike?
It will have 21 speeds.
It will have 21 speeds. Well, let's go ask the bike, how many speeds do you have? Talk to the bike. And we want get maximum gears. And how would you know if you got the right number? What number do you expect it to be? 21. So this is, I think that speeds, what the bike said, should be exactly equal to 21. Okay. Anything else? When in doubt, go back and look at the data that you were keeping.
Wouldn't you want to confirm that pedaling makes it go forward?
We're just looking at the bike. You can't go on it because if you ride it, you pay for it. So we're just standing there looking at the bike, asking it questions, sort of working our way around it. Can't actually approach and touch the bike to get it to do anything.
Use the right variable there on your test. You're asking how many gears it has.
Oh, gears? Okay. Sorry, it should be gears. There's the joy of having good variables. Got it. So the bike has gears. What other information does it have?
It's not moving.
It shouldn't be moving.
I think I'd still buy a bike if it could move by itself, actually. Be a little impressive.
And I think that the speed should be exactly 0. Anything else?
The factory setting for the gear should be 1.
It should be in some gear, so the it should the chain should be on the gears. And if they did it right, they basically promised at this point that current gear. Notice this is a different current gear variable. This is mine rather than the bike's. Talk to my bike. Ask it what current gear it's in, and I think that current gear should be 1. Now I'm going to ignore the test for the string at this point. Well, no, let's put it in. What the heck? Talk to the bike. Oh, gee, we don't have get owner name because it doesn't appear in the list. So one of the things we missed in the bike, even though we put that thing in there, is we didn't do a public string get owner name that sends back the owner name. Okay, so that'll make our test a little better. We can now do dot get owner name, and I think that the owner name should be, and we'll use the actual string matching here, empty. Nothing in it. What did we set the owner name to? Okay, so a good thing to do here would be to say owner name is an empty string, which is different from no string. Okay, so this is, it's got a blank on it.
Can you test for an empty string?
That is basically an empty string rather than no string. Okay. Now if you run the unit tests, there's a test to see whether or not it's made correctly. Yep. We got our bike from the factory and looks like it's okay. So, time for another test. What do you want to test next?
Reopening the packet in the bike yet?
Yeah, now you can play with the bike. Now you've accepted it, you paid your money.
So the pedaling forward goes forward and the brakes actually
So
slow down.
you would expect that pedaling forward should work. So we'll make a test. And typically the thing that you do here is we're going to start out and we're not going to do anything really complicated in the tests. So I'm going to make my brand new bicycle. I've already tested to make sure that it's in its initial state, so I don't have to retest that. At this point, I can do my bike dot pedal. Now what?
Assert speed equals 1. Assert curve.
So if you pedaled, what's your expectation?
Go up by +1 for each pedal, nothing more.
So talk to the bike and say get speed, and then what?
Didn't you say there's like 4 pedals, so speed should
pedal once, shouldn't it be 2?
Started out at 0.
Usually.
And also, if the driver is pedaling it 4 times, would you have to say that it should be true or
But
false?
the drivers, we're trashing the driver now, and we're just worried about what does each one of these tests do. If it were me, unless I called this test pedal once, because in order to pedal 2 or 3 or 4 times, I want to make sure that just one works correctly. And if the first pedaling doesn't work, if the bike doesn't go any faster than the first one, I already know it's broken. Okay, so I'm going to make one test that just does once, and then you can do another test later on that just does multiple things. Is there another way of writing this test that would be maybe a little bit more generic? Instead of testing to see that it's 1 greater than 0.
Greater than 0?
Or a little bit more general than greater than 0. What's the difference between of your bike before and after?
Speed increase.
Not speed's gone up. So a more general thing, rather than saying it's exactly 1, would be to say the speed has gone up from what it was when I originally got it. So another way that you could write this thing is you could find out what the speed was before you pedaled, then you could pedal it, and then you could say, well, I think in this case, if I've got the current speed, we could change this to say that current speed is greater than old speed, which would also work. So it depends on how specific you want to be in your test. If you were looking for a specific number, that's fine.
Wouldn't that not take it though, to say it was going up by 2, and you would have a difference and it would be good to go, but you would be increasing?
At this point, I'm only interested that it goes faster.
Okay.
Right, so this is a general, gee, I wonder if it goes faster than it was when it started for the first test. Okay. Now notice that this thing is also where we're basically defining the behaviors, because at some point if we say the bike needs to go up by a factor of gears, right, for speed, then this is the place where you would go in and you would define that to say, okay, if it's in gear 1, it's going to go up by 5. If it's in gear 2, it's going to go up by some other amount of speed, right? That's the point where you'd make it by the gears, and then we'd have to rewrite the code to make the code, instead of going plus plus, agree with what the functional test said it was supposed to be. So generally you want to write this thing first, the test to define the behavior, and then write the code afterwards to make it match what the test says. Okay, one last quick trick for the thing here. Let's just talk about this code that we put in for gear up. I'm going to write a quick test for because somebody was concerned about whether or not gear up worked correctly. That's the first one that we put in some limits. So we would still make a brand new bicycle. Oops. There's our brand new bicycle, and then we would do my bike So what are you going to write to see whether or not it doesn't exceed the maximum gear? Couple of choices here. It's like you're good programmers, so the sort of the first thing you want to do is say, well, we just have to gear up a bunch of times, so let's write a loop to do this. I is less than 21, whatever it happens to be. Just do a whole bunch of gear up. And then the assert statement would be, I think that my bike dot get current gear is still stuck at 21. Now, quick thing here, notice I left out the variable. You can do this, you can leave out the variable on this statement, and this assert statement will still work. The problem with leaving out the variable is if it breaks, it's really difficult to see the value. Okay, because you'd have to sort of try to step into the assert true and then try to step into current year to see what value it was returning. So this style of, in the unit test, of making a variable to record it means that when you're using the debugger, you can click through and it'll show you what the value is really easily without you having to hunt for it. So in general, you're always better off to put things into variables because that's a nice debugger skill. Okay? So there's one way of doing it. Is that the best way? Can you explain that thing to Mom? Oh, man. I mean, my mom's pretty smart, but she's probably not going to want to listen to me explaining it. So the other alternative, I suppose, is do a whole bunch of those. But then people would have to count. So what's a sneakier way of doing this?
My bike gear up 22. Is that the same thing?
Another little programmer trick. What's the problem here, really? The 21 is the problem, because that's what's making the repetition. So how do we get rid of the 21? Make the problem smaller.
New bike 5.
Let's have a bike that's way smaller. So let's go back to the good old days. I don't want one gear on the bike because then I can't change it. I don't want too many and I don't want too few. 2 is probably not enough. So 3 is about the right number, because now that means when I'm showing this to Mom, I can do this. I'm going to say, I'll actually write it a little bit differently. We'll just stick an assert between each one of these. Current gear should have gone from 1 to 2. And if we want, just to make it clearer, watch this. We'll say it should start in gear number 1. I do a gear up and it should be gear 2. One last little minor change. I do another gear up and it should be 3. Okay, and then if I do one final gear up, it should stay at 3. And notice what I said about patterns. I can give this test to Mom. I can walk her through it really, really quickly and went, look, Mom, I had a 3-speed bicycle. It started out in gear number 1. I geared up a bunch of times. I geared up one more than it was supposed to be, and it still stayed in gear 3. And my mom and probably your mom can understand that explanation and see the pattern. Way easier than loops. We didn't get stuck with, is it less than or equal to hit the maximum. We knew exactly what it was from the test. It's pretty much self-explanatory. So this is why I say in these unit tests, loops aren't necessarily a good idea. They just make the problem worse. And there's the little programmer trick. Downsize the problem to something reasonable, and now you've got the ability to test it real easily. And we're done.